Number 20 says, after hearing of the national result that 44% of students engage in binge drinking, 5 drinks at a sitting for men and 4 for women, a professor surveyed a random sample of 244 students at his college and found that 96 of them admitted to binge drinking in the past week. Should he be surprised at this result? So, for this problem, it's telling us that the national result is 44%. So P is 0.44. That's what they believe the national percentage of college students who have binge drinking. And then this sample is P hat. The sample the professor took was 96 out of 244. So the P hat was the sample he took, and the P is the statistic for the nation. So is the result at his classes surprising based on the national statistic? That's what it's asking. So 96 out of 244, hold on, is 0.393. Okay. So conditions. It says the professor surveyed a random sample. Sample was random. Remember that just writing random, check. Success, failure, check. 10%, check, is not checking conditions, and you will not get credit for that. Okay, I saw it on your paper. I saw this, CLT, check. What does that mean? What did you check for this? What? No, I give you credit on the homework, but you ain't going to get credit on the quiz. Right? If you just write CLT check, you are not explaining what you are using the central limit theorem for. You need to say, and this problem doesn't have central limit theorem, that this many people in the sample is large enough to apply the central limit theorem, and therefore a normal model is appropriate. You can't just say central limit theorem check. That's not going to get you credit for that. You can't just say random check and 10% check. You have to say 244 is less than 10% of all students. What is it less than 10% of? That has to be reasonable. Jalen. So if I have proportions, I'm going to check success failure. So if I have P's, I'm going to check NP and NQ. If I have a mean and the standard deviation, then I'm going to use the CLT. Okay, so the conditions for proportions are NP greater than or equal to 10 and NQ greater than or equal to 10. And I can't just write that. I need to actually do the calculations. 244 times 0.44. I'm not using the numerator of the P hat because I know the population proportion, and I want to know with the 44%, do I expect 10 successes and failures? This is different from chapter 19. Yeah.
Sorry, this might seem like a dumb question, but I've been kind of struggling with, like, when do you know to check conditions?
Always. Always check your conditions. You can't go wrong by checking your conditions if it wasn't necessary. If you don't check your conditions and it was necessary, you just missed half the problem. Okay, so always check your conditions. At this point forward, always check your conditions, unless it says, assume all conditions are met, or all conditions are met, so you can move on and not have to do that. And if it doesn't tell you all conditions are met, you have to check conditions. Yeah. Tomorrow. Robin. You still have to check your random sample, and then you can say for this instead of using the central limit theorem, you want to say the model is normal. But you still have to check random and 10%, because it still has to be independent. Layla.
Does it matter, like, should we check conditions first and then do these?
Yes. Yes, because if conditions aren't met, you technically shouldn't be doing any of the calculations. If the conditions are not met, you can't use the normal model. That's not an appropriate calculation. And so it doesn't apply to that problem. So the conditions have to be checked first to make sure that the normal model is appropriate. I You will have some in the homework, yes, where the conditions are not met, and so you do not have to move on. I've never seen it on an AP exam, because I figure they're not going to give you that out, right? But I have seen problems where it asks only about the conditions and says, do not perform the test. And so then there, it could go either way. Aiden? Absolutely. Especially for the confidence intervals. That's like step number 1, check conditions. Step number 2, create your interval. Step number 3, interpret your interval. Okay, and we'll go over that more today. Was there another question? So the question is, when do I check conditions? The answer is always. Okay, unless it says you do not have to check conditions. Check your conditions. Okay. And so 244 times 0.56 is 136.64. On the success failure condition, if you don't actually perform that calculation and write down 107.36, you're not getting credit for that condition. You have to show that you did the calculation and you know that the numbers are greater than 10. Not, well, obviously, 44% of 244 is more than 10. No, you have to show the number. Layla.
So, while we're checking conditions, say like this, it wasn't less than 10% of like whatever, do you still want to check all of them, or can you just say since conditions aren't met?
Check all the rest of them, because most of the time that 10% condition is going to be reasonable unless they tell you how large the population is. So the only time really the 10% condition is not going to meet is if they said like, the professor did a sample of 244 kids of the 2,000 school population. In that case, your 10% isn't met, right? Because 244 is greater than 10% of 2,000. But you have to know the population, the number, in order to actually say that it's not less than 10%. Kylie?
So when we're doing the CLT condition, do you just say that it applies to the...
You will say the sample size of 25 or 50 or 244 is large enough to apply the central limit theorem. Has to be greater than 25. So then we say, since conditions are met, a normal model is appropriate. This will be worth 4 points on each problem on the quiz. That's a total of 8 out of 20 points that are just conditions. So that means if you don't check any conditions, you can't get above a 60% tomorrow on the quiz. 2. 2 questions. 1 proportion, 1 mean. Well, yeah, it's the first quiz, so. Which is why it's important to make sure you're checking conditions in the homework and not getting lazy, because then what happens is you forget to check them on the quiz because you haven't gotten into that habit, right? You've forgotten what they are because you're not doing it the right way on the homework. Okay, so now I can answer my question. Find my z-score. 0.393 minus 0.44 over, what's my standard deviation? Is the square root of 0.44, 0.56 over 244. Square root of PQ over N. You can only use PQ over N if you have a P. Yeah. If you have a P, then you have a Q. What? So 0.393 minus 0.44 divided by 0.0318 is negative 1.478. So the question was not what's the probability of getting a sample, it was should he be surprised at this result? It's lower than the national average, but is it low enough for us to say, wow, this college really has a lot of kids that don't drink or binge drink? Is it low enough to be surprised? No. Why? It's within 2 standard deviations. So I have to answer the question. I can't just say negative 1.478 and move on with my problem. I didn't answer the question. Okay? The question is, where'd it go? Should he be surprised at this result? So the answer is no. He should not be surprised at this result because his sample lies within 2 standard deviations. I did not spell that right. Of the mean. So make sure you answer the question. That's huge on the AP exam. If it asks a yes or no question and you don't answer the yes or no question, you've missed a whole point on that free response just because you didn't say, no, he should not be surprised. Yes, he should be surprised, and why? Okay. All right, other questions on this problem? Okay, so number 48. The weight of potato chips in a medium-sized bag is stated to be 10 ounces. Yeah, these are the chapter 18 problems. The amount that the packaging machine puts in these bags is believed to have a normal model with a mean of 10.2 ounces and a standard deviation of 0.12 ounces. What fraction of all bags sold are underweight? Okay. Underweight, the standard is 10 ounces. 10-ounce bag of chips. What percentage of all the bags are going to be less than 10 ounces? How do I find that? Told us a normal model applies because we're talking about one bag. We're talking about chapter 6 calculation. So it's my z is 10 minus 10.2 over 0.12. Which is negative 1.667. And then I can find that normal CDF, negative 99, comma negative 1.667. Why is it less than? Because I want to know the probability that it's less than 10 ounces. That would be underweight, right? And I get 0.0478. So 4.78% of bags are expected to be underweight. Some of the chips are sold in bargain packs of 3 bags. What's the probability that none of the 3 is underweight? It's actually binomial. This digs back to chapter 17. The probability that it's underweight is 0.478. What's the probability that none of the 3 are underweight? So what's the probability that it's not underweight? 0.9522, right? 0.9522. This was 1 minus 0.0478. The probability that it is underweight would be 4%. The probability that it's not is about, or 4.7%, and the probability that it's not underweight is 0.95. None of them being overweight, none of 3 bags, would be 0.9522 to the third power. 0.863. Yes? This will not be on the quiz. Might be on the AP exam, won't be on your test. No, one of this will not be on the quiz. The one like number 20, and like what we're going to do for C and D. Devin. Oh. Faith?
So, again, probably conditions. When are we going to need to, like, for sure draw out the, like, model? Is it only when it's asking, like, I mean, not the model, but, like, the 65,
It would have to say use the 68, 95, 99.7 rule or the empirical rule to describe the distribution or something like that. That will not be under quiz.
It actually says like describe this distribution. It wants to say 68% is between whatever our opinions, right?
If it says, yeah, use the empirical rule to describe it, yeah, or describe what you might see in a sample of this. If it just says to identify the model and the shape and the spread and the parameters, that's just saying this is the normal. You check your conditions to say that it's normal, and this is the mean and the new standard deviation.
wait, can you say that's not going to be on the quiz?
To describe the normal model, to do the 68, 95, no, that's not. It's just going to be like the first problem is going to be like this one, a proportion. Second problem will be a mean problem. One of them you'll have to calculate the normal CDF, and the other you'll just have to say, is this unlikely or is it unusual? And you have to check conditions on both problems. Letter C says, what's the probability that the mean weight of the 3 bags is below the stated amount? Now, 3 is not large enough to apply the central limit theorem, right? But it is coming from a normal population. It's normally distributed, so we can use it. So we'll look at our conditions. As soon as I'm talking about taking a sample of 3 and finding that mean, I'm checking conditions. Okay? The condition for A was already met when it says it's believed to follow a normal model. Okay, so a normal model applies for A. For C, it has to be random. It says, what's the probability that the mean weight of the 3 bags? Well, it's probably not random. It's probably just 3 in a row on the conveyor belt, but they're probably representative, right? So the bags of chips are representative. No, I can't spell this morning. Remember that we only use representative if it does not say random. Okay, if it doesn't say it's randomly sampled, then you use representative. 3 is less than 10% of all bags of chips. And then although 3 is not a large sample, the population is believed to be normal. And I may be cheating. Does the book say conditions aren't met? Or does it do the calculation? It does the calculation. I thought so. So since conditions are met, a normal model is appropriate. Again, 4 points on the quiz. Okay, if it's the sample size is 30 or 400, 400 is large enough to apply the central limit theorem. That's this condition instead of the NP and NQ, because you don't have an NP and NQ. If the population is not normal, then it has to be greater than 25, the sample size. right? Because you're pulling from a skewed population, and the only way the sampling distribution will be normal is if the sample size is large enough. Okay, yeah. It will say in the problem, like this problem says that the chips, it says the packaging machine puts in these bags or the amount that the packaging machine puts in these bags is believed to have a normal model. So it's telling you that the population has a normal model. Yeah. Right. If it's skewed, and my sample size is 3, like we talked about the tips at the table yesterday, right? Well, we believed that the amount of tips the waiter got was skewed to the right. So a table looking at only 3 tables, we can't use the normal model because that's not large enough to apply the central limit theorem. But we could look at all his tables over the weekend, all 40 tables over the weekend, because 40 is a large enough sample to apply the central limit theorem to a skewed model. Okay? Remember that threshold is like 25, right? N has to be greater than 25 to apply the central limit theorem. Okay, so my normal model here is 10.2 and 0.12 over the square root of 3. That's my standard deviation. Sigma over square root n. So what's the probability that the average of the 3 bags is less than 10 ounces? So my z-score is 10 minus 10.2 over 0.069. That's negative 2.887. And then normal CDF, negative 99. Right? It's negative because of the less than. And we get 0.00195. So there is a 0.00195 chance that 3 bags average less than 10 ounces. D says, what's the probability that the mean weight of a 24-bag case of potato chips is less than 10? I can still apply the central limit theorem because remember the population is normal. So for D, it changes my standard deviation. It's 1.12 over the square root of 24 bags. When my sample size changes, my standard deviation changes, right? So it's the same calculation with the new standard deviation. So negative 0.2 divided by that standard deviation, negative 8.165. And my calculator literally says 0. 0. There's a 0 chance of a 24 box of chips having an average of less than 10 ounces. But that weight does include the air. Like they're talking about the actual amount of chips in the bag. Yeah, I know. It's all deceiving. I hate it. You open the big old bag of chips, it's like a quarter filled.